Welcome to monochemistry. Today we're going to look at a specific type of hydrocarbon called an alkane. Now this flowchart will kind of summarize a little bit about what we've talked about so far and introduce the new idea of an alkane. So remember that organic compounds, as it says in the chart, always contain carbon and hydrogen. They must be molecules. They can also contain other atoms in certain situations, and they can be synthetic, which is human-made, or natural. They can occur in nature. There are two major groups of organic compounds. There are the hydrocarbons, which only contain carbon and hydrogen. Remember, those are the ones that are generally found in our fossil fuels or derived from the fossil fuels, and hydrocarbon derivatives, which usually will contain other atoms as well as carbon and hydrogen. Now, underneath the hydrocarbons themselves, there's two groups of hydrocarbons. The first one is called aliphatic hydrocarbons, and they're not based on a particular type of structure called a benzene ring. Aromatic hydrocarbons, on the other hand, are based on the benzene ring. The benzene ring is something that we'll discuss a little bit later in the course, but it's a structure that has, obviously it's a ring structure that has a series of double bonds. And aliphatic hydrocarbons, the ones we're going to focus on in this unit, do not have that. Now there are three types of aliphatic hydrocarbons. There are alkanes, alkenes, and alkynes. The one we're going to look at specifically today are the alkanes. And alkanes contain single bonds only. Let's look at a definition. Alkanes are hydrocarbon molecules that only have single covalent bonds. And in this drawing down here, you can see that there are, in this particular drawing, there's one carbon and four hydrogens. Notice that there's only single bonds. Now you might be wondering what the heck this is. This is a line diagram. I know in the past I've called these line diagrams, but in fact these are what are known as structural diagrams because they include all of the atoms that are involved in the molecule. This is a true line diagram. I mean, look at it. It's just lines. So what the heck does it mean? We'll talk about that a little bit later. But before we do that, I want to talk a little bit about how you can determine, based on the name of an alkane, how many carbons and hydrogens are in it. Okay? So there's what we call a general formula. So if you know something is an alkane, and we'll talk about that in a minute, how you can determine that, but if you know something is an alkane, then here's how you would determine the number of atoms and the type of atoms that are in it. Alright, so if you have an alkane, the general formula for an alkane is this: CnH2n plus 2. Now let's just think about that. So N is the number of carbons. So let's look at methane. The number of carbons in methane is 1. So it would be C1. Now, if I didn't have this picture here, and I didn't know how many hydrogens were there, I could use this general formula to figure it out. So if N is equal to 1, then H is going to be equal to 2 times 1, which is 2, plus 2. So it would be C1H4. And look at that. That's exactly what we have for this one here. Okay, so this formula right here is very important. If you have the name of the hydrocarbon and you know it's an alkane, you can use that formula to figure out exactly how many carbons and hydrogens should be in the molecule so that you can draw it properly. Then, of course, the question becomes, how do you figure out how many carbons specifically there are from a name? Well, this little table here is going to become your best friend. As you can see in the table, and you should copy this into your notes, just like you did the first screen, the number of carbons is listed here from 1 to 10. You don't have to know beyond 10. They can go bigger than 10, but you don't have to know beyond 10. You need to know 1 to 10 though. So if there's 1 carbon in the substance, you start with the prefix. Prefixes go at the beginning of words. That's what a prefix is. Okay, so you start with the prefix meth. If you have 2, it's eth. 3 is prop. 4 is bute. Bute I put there just because it would look like but otherwise. 5 is penta. 6 is hexa. 7 is hepta. 8 is octa. 9 is nona. And 10 is deca. You probably recognize certain ones of those like penta, hexa, octa, and deca. You've probably heard those before. Okay, so some of them you may not have a problem memorizing. In the past, some of my students have come up with sentences that help them remember the order of these. I can't think of one off the top of my head, but if you start a sentence with the word M and then the next word has to start with E, etc., it might help you remember it. But you do need to remember this. So first of all, start by copying it into your notes. And second of all, we'll practice a lot and hopefully you'll get to know them pretty well. Alright, so if I was naming a hydrocarbon, especially an alkane, the reason these are important is because if I knew I had CH4, if I knew I had CH4, okay, I would look at that and I would say, okay, well, CH4 has 1 carbon, so it's got to be meth. Now, I know that this is an alkane because the general formula CnH2n plus 2 tells me that it's an alkane. So now that I know this is an alkane, I'm going to start with my prefix, which is meth. And because it's an alkane, I finish with an ANE. Can you think of any other hydrocarbons that end in ANE, like propane? Okay, so propane and octane are actually alkanes. Okay, so here's the prefix and here's the ending of the word. Notice ANE, just the same as if I was to write the word alkane, ANE. That's how you know that it's an alkane. If it ends in ANE, it's an alkane. The first part of the word, like meth, tells me how many carbons are in it and therefore how many hydrogens are in it. Let's try one. Okay, so drawing alkanes. There's a couple different ways to draw. We're going to look at this now. Number 1, you can do a Lewis dot diagram. Number 2, you can do a structural diagram. And number 3, you can do a line diagram. We're going to skip the Lewis dot diagram here, but we're going to draw propane. Now, if you look at your handy-dandy chart, propane has 3 carbons. So we're going to write C3. Now, using our general formula, which is CnH2n plus 2, CnH2n plus 2, how many hydrogens would be in propane? Do, 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 do. And the answer is, of course, 17. No, I'm just kidding. 8. So C3H8, because 2 times 3 is 6, plus 2 more would be 8. So C3H8. So I'm going to draw that. Well, how do I do that? Watch. 1, 2, 3. Now, as we've learned in the previous unit, every carbon has to form how many bonds? I won't do the Jeopardy music again. It's 4. Okay? So, watch what I do. I look at each carbon and I say, okay, this carbon here only has 1 bond so far. So I'm going to have to put 1, 2, 3 more. This one in the center has 2 bonds already, so I'm going to put 2 more. This one here has 1, so I'm going to put 3. See all those spaces there? Those are for the hydrogens. Now there should be 8, if my math was correct. Okay, and there's propane. That's how you do a structural diagram for propane. Now, you know, in chemistry, we have all these abbreviations. We really like to take shortcuts. We don't want to have to do a whole lot of extra work if we can avoid it. So watch this. This is also propane. Pretty cool, huh? Okay, so how did I do that? Well, I started here, and I said that's carbon number 1. I drew a line up to a point to represent carbon number 2. I drew a line down to another point to represent carbon number 3. 1, 2, 3 carbons. Now, as long as these carbons are only bonded to hydrogens, which they are, I don't have to do anything else. That's propane. Now, I could also draw it like this. That's also propane. I can't draw it like this, though, because that doesn't show 3 carbons. That only shows 2 carbons. So get rid of that. All right, what I want you to do now, and we'll go over this in class tomorrow, I want you to pick 2, now let's make it 3 other hydrocarbons that are bigger than propane, and I want you to draw both the structural diagrams and I want you to try the line diagrams for each of those. Just practice, see what you can do with them. And that, in a nutshell, is what an alkane is and basically how to draw them. Bring your questions to class.